Hi guys, and welcome to another digital pre-algebra lesson. Today we're going to talk about lesson 10.6, and we're going to talk about surface area of pyramids, cones, and spheres. Last time in class we talked about, or last lesson, we talked about surface area, but about two other shapes. So let's go ahead and start today's class, a little bit of a recap about what surface area is and what shapes we talked about last time. Previously, we talked about the surface area of prisms and cylinders. Prisms were three-dimensional shapes that had two bases. The bases were always parallel to each other. And in this case, we had a rectangular prism. We also had triangular prisms. We found the surface area by using this formula. The surface area is equal to the lateral area plus 2 times the area of the base. The lateral area for any prism is the perimeter of the base times the height. And that meant that in order to solve this, we needed to find three things. The perimeter of the base, the distance around the outside of the base. Like in this example right here, the perimeter of the base would be this plus that plus these guys, right? Or this is part of the base, this is part of the triangular base, this is part of the triangular base. So the perimeter would be these distances added up together. Plus 2 times the area of the base. Why was it 2 times? Where did this 2 come from? Well, if we were trying to find the surface area, the added space around the entire outside of the figure, each prism has two bases, so we have 2 times b. The cylinder had a similar setup, but it looks a little different. The surface area for the cylinder is 2 times pi times r times h plus 2 times pi r squared. In order to find this, we only needed to know two things. The radius of the circle. The radius of the circle is from the center of the circle to the outside edge. That would be the radius. And the height of the cylinder went from the floor to the ceiling, from the bottom of the figure to the top. If we have these two items, then we can go ahead and plug them in and find our area. And remember, all areas are square area. Cool? Remember? Cool. Now today's lesson is going to talk about three new shapes for you, three new space figures and surface areas that we can find for those space figures. We're going to talk about pyramids, cones, and spheres. Now I went ahead and wrote all of the really important information onto this one screen to kind of show you the differences and similarities between the different shapes. Alright, now first let's go ahead and start talking about pyramids. Alright, this is an example of a pyramid. A pyramid is a space figure that has a singular base, but instead of having a second base on the top, it has a vertex. It has one single point where all of the edges meet. Alright, so in this case, the surface area formula will be the lateral area plus b, which is the area of the base. Alright, so let's go ahead and write that here. Just a reminder that this is the area of the base. Now notice with this problem, compared to the last lesson had 2 times b. This one only has 1b because a pyramid only has one base. So, one way that we can simplify this in the equation I suggest that you use is going to be this guy, the one in red, where the lateral area is the same thing as the perimeter of the base times what we're going to call the slant length. This is called the slant length, alright, divided by 2. Alright, so the slant length is going to be the distance from the middle of the pyramid all the way to the vertex. And this is going to be a given number for you guys in your problem. Plus the area of the base. Now, pyramids could have square bases, they could have rectangular bases, they could have triangular bases. So just so you guys know, the base shape might change. So this base might just be the traditional base times height, or it could even be something like base times height divided by 2 if it is a triangle. This is for parallelogram. Okay, so if we have a problem involving a pyramid, surface area of a pyramid, we're going to be using this formula. And these are the only 3 things you need to know. If you have these 3 things, you'll have everything you need to know to solve for the surface area. Now let's go ahead and talk about cones. This is an example of a cone, very similar looking to a pyramid, where it has one base and it has a vertex, but a cone will always have a circular base. For that reason, this base is always going to be pi r squared. The lateral area for a cone is pi times r times the slant length. So I gave you kind of 2 options. You can say the surface area is pi times r times the slant length plus pi r squared. Or some people might notice and might think this is helpful, that r squared is the same thing as r times r. All right, so maybe specifically for the people who are having trouble typing into the calculator and getting different answers, maybe instead of doing r squared and possibly forgetting the square, you guys are multiplying r times r. In order to solve for the surface area of a cone, you only need 2 new things. You need to know the radius of the base and the slant length. And I put as a reminder that pi is the same thing as 3.14. If you have the radius and if you have the slant length, you can find the surface area of the cone. Spheres are actually probably the simplest of all the shapes because there's really no way around it. We only have this basic formula. The surface area for a sphere is 4 times pi times r squared. Again, some people might notice that r squared is the same thing as r times r. So maybe this is a better equation for you guys to use. Either way is pretty simple, and the only thing you need to know to solve for the surface area of a sphere is the radius. If you have the radius, then you can just go ahead and plug this into a calculator and you have everything that you need. So for surface area of pyramids, cones, and spheres, it's actually not as bad as the last lesson. We just have to know what we're looking for. And these guys down here are what we need in order to solve our problem. So let's go ahead and look at one problem involving finding the surface area of a pyramid. Okay, so for this problem, we're going to go ahead and just look back at our notes, and we're going to establish that the surface area of a pyramid is going to be the same thing as perimeter times slant length divided by 2 plus the area of the base. And the 3 things we need in order to solve for this problem are perimeter, slant length, and the area of the base. Alright, so if we have these 3 things, then we can find our answer. So the first thing you want to do is figure out, well, what is the perimeter of the base? Well, the perimeter of the base is going to be this line plus this line plus this line plus this line. And because this looks like it's a square, it's going to have 12 all the way around. This is the same thing as 12 plus 12 plus 12 plus 12, or the same thing as 4 times 12, which is going to be 48. The perimeter of the base is going to be 48 centimeters. The slant length is given to us. This is the slant length, so it's going to be 16 centimeters. And the area of the base is just going to be, because this is a square, it's going to be base times height, which is going to be 12 centimeters times 12 centimeters. Now this is going to be 144 centimeters. So the surface area is going to be, just plugging all of this stuff in, 48 times 16 divided by 2 plus the area of the base is 144. Now notice we only have one base in the problem, so we only have one base up here. Does anything cross cancel? Yeah. We got a 2 and a 16 becomes a 1 and an 8. So if I take a calculator out and figure out what's 48 times 8, I'm going to get 384 plus 144. This is going to give us 528 centimeters squared, because this is an area and area is square area. So remember, for this problem, all we need are these three things: the perimeter, the slant length, and the area of the base. The area of the base may change based on the shape. This time we have a square, so I just went ahead and figured out the area of a square. Now let's take a look at how to find the surface area of a cone. Looking back at our notes, we said that the surface area of a cone is going to be the same thing as pi r slant length plus the area of the base, and the area of a circle is pi r squared. Now, I chose to write r times r just because that might be a little bit easier for us when we're typing into a calculator. In order to solve this one, it looks like we only need two things. We need the radius of the base and the slant length. Looking at this circle, we have a radius here, so this is going to be 4 centimeters, and the slant length is going to be 10 centimeters. Cool? Nice and easy. So that means that if we plug this information in, the surface area is going to equal to 3.14 times the radius is 4 times the slant length is 10 plus 3.14 times 4 times 4. We plug this into a calculator, and if I say 3.14 times 4 times 10, I get 125.6. And if I say 3.14 times 4 times 4, I get 50.24. If I add them together, 125.6 plus 50.24, I get 175.84. And this would be centimeters squared, which is approximately 176 centimeters squared. Cool. For the last example of the lesson, we're going to turn to California Standards Check number 3, where it asks to find the surface area of a sphere. In the lesson, we said that the surface area of a sphere is 4 times pi times radius squared. So all we need is the radius. For this problem, it says a sphere has a radius of 6 centimeters. So the radius is equal to 6. The surface area is equal to 4 times 3.14 times 6 times 6. If we multiply all of these together, 4 times 3.14 times 6 times 6, I'm going to get 452.16 centimeters squared, which is approximately 452 centimeters squared, because we're talking about surface area, and area is square area. Alright, just be careful. Sometimes they give you guys a diameter instead of a radius, but the diameter, the radius is just the diameter divided by 2. Right? But overall, that's how this lesson works. Hopefully I made this as simple as possible. Good luck, have fun, go do math. See ya.